Right, so now we're going to look at combining events using the word or. So the word or is usually interpreted to mean union. So our union of sets A and B, symbolized A, U, B, is a set containing all elements that are members of set A or set B or both. Right, so we see that we flip the symbol. Our intersection is an upside down U, our union is a right side up U. And instead of just looking at the area in the middle, we want everything that's in the middle, that's both sets, and everything that's over here, or everything that's over here. So or means either A or B or both. It's an inclusive or. Right? When we're going through and we're working on these problems, we just want to make sure that we are not accidentally counting the same group more than once. So that is something that we are going to want to watch out for. All right. So let's go back to our little Venn diagram with our hats and glasses. This time we are looking for or. So what is the probability that the person is wearing a hat? And that is a huge typo right there. This should definitely be the word or. All right, hat or glasses. All right, so hat or glasses means we want anyone wearing a hat, anyone wearing glasses, or anyone wearing both. So we are going to put a circle around all 5 of these people. All right. We still have one person outside, so 5 out of 6, which is 0.833 repeating, or 83.3%. Right, so like we did with our and, we're going to look at, again, kind of a more sophisticated example. It's actually the same example or same table, I should say, different type of example. When we're going to be looking at our education or marital status. Right. So the table below shows the education and marital status for 665 randomly selected people. Right. So what is the probability that the person is single or married? Right. So what we can do, again, I'm going to kind of show circles to show what we have here. So the probability that somebody is single, right? All of these single people add up to 112, right? And all of these married people add up to 408, right? So we're going to take 112 plus 408, add those together, and then divide by our total of 665. So that gives us 520 divided by 665, which is 0.782, or 78.2%. Right, so in this particular example, we just use 2 different columns, use that number from those 2 different columns to add up to get our total. There is no overlap between these two, right? You're either single or you're married, but you're not both. So we could just use the numbers that were at the bottom. Right, so then for B, what is the probability that the person is married or has a college education or higher? Right, so if we look at this, we see we have a row being intersected with our column here. So what we want to do is we want to treat this a little bit differently, right? So we want to make sure that we don't count this group of people twice. So instead of circling the numbers that I have at the bottom, I'm just going to circle my rows and columns accordingly. So the number of people that are married, right? If we look at these individual groups, those people are all married and it adds up to 408. Right? If we look at the people that have a college education or higher, right, all of those 4 groups add up to our total of 143. Right? Again, the reason I'm doing this differently is we want to make sure that we do not want to count these 98 people twice. And we will get a kind of a little shortcut to do this. But for right now, what I'm going to do is I'm just going to go through and list out all of these different numbers. So our people that are married, we have 70 plus 240 plus 98. The people that have a college education, 27 plus, well, the 98 we already used, so we don't want to list it again. And we're just going to do plus 15 plus 3. This is going to give us 453 divided by 665, which is 0.681 or 68.1%. Right. And the reason that we did this one slightly differently than we did the last one is because there was an overlap, and we want to make sure we don't accidentally count that group of people twice. Right? And then in the next example, we're going to kind of take a closer look at this and kind of revisit these last two examples and give us another way to kind of go through and determine these without having to go through and add all of these individual numbers like we did in part B of this example.